In this exercise, binary search tree, we'll be doing test-driven development in Node, and we'll be taking some existing code that can already build a binary search tree, and we'll be adding a search to it. So the code we will look at will have that first bit of application code and the tests for it, which is great. And it actually will have some additional tests for code that doesn't exist. Apparently the developer absconded in the middle of the night, and it's our job, should we decide to accept it, to fulfill that contract, those test contracts that we have with actual application code. And as is the nature of a binary search tree, it'll be something that's recursive. And I've brought up a little diagram here. Don't usually do a lot of theory, but this if you don't know what a binary search tree is, you do need to know just some of the basics. It's simply a way of starting at one point, which is always called the root node, and then looking down. There's either a left or a right. In each case, there's a left or a right. These are just images from Google. And the way it works is that if you start here and you look at a value, if it's less than that value, you go to here. If it's greater than that value, you go to here. So you can, take this one here, you can take 17 different data points, and within 1, 2, 3, 4 at most, 1, 2, 3, 4, you can find whether a given value exists. And beyond that, if it's less or greater than that, then it doesn't exist. So you can add a node, which is the code that we have already existing, just to go down and find out whether there's a blank one or an existing one, and whether it should be a left or a right. And that's why they're always just called binary search trees, because there's just always two options from any given node. They're like pointers to another node, a left or a right. And the one node that's really special that you have to always start with is the root node, because that will give you access to all the what's called leaf nodes at the base, the ability to get to those by traversing down the tree. So that's what a binary search tree is, and like I said, we're going to be fulfilling these test contracts. So let's get started. Okay, let's get set up. I'm going to share this setup between all of my exercises to make it a little bit easier. So let's get going. So I'm going to create a directory to work in, app. And you see our Explorer here is keeping up with us. This is VS Code. I'm going to go into that directory, and I'm going to use Node. So I'm going to create my package.json file. There it is. It's a simple template. And let's start installing the tools I'm going to use. And they're going to be dev tools. So first of all, for testing, Mocha and Chai for expectations. And then ESLint and ESLint plugin Mocha, because I'm using Mocha. Alright, and then one final thing while I'm at it, I might as well install NYC for code coverage while I'm here. It's a successor to Istanbul. Okay, good. So that's the three of those. You can see our package.json file. It's got our dependencies. It doesn't do anything with our test command yet, so I need to fix that. But first of all, let's copy in this ESLint RC YAML file that I've got. And you can see here, there's a ton of rules. I love having loads of rules to guide me, in errors and warnings. So it's very, very handy. I love that. All right. That's the ESLint YAML file, and here's our scripts where we want to actually put in running tests. So let's put in the actual command we're going to use, which is going to be Mocha. We'll just use the top level, anything that's called star.test.js. Okay, so we should actually be pretty close to be able to run tests. Let's try to do it with npm test. And no files found, but no actual error. So let's go ahead. We'll use index because that's what the auto generation of the package.json used. And we'll put in our index.test.js, which is actually the file it'll recognize. Alright, so it's green. No test, but the framework's there. Alright, so let's put in the other pieces now. Let's put in the linting, which is going to be our pre-test, so it's going to run before the tests can even run, and that's going to be ESLint everything. And while we're here, let's put in our code coverage, and that's going to be the NYC npm run test. So that's close to all of the pieces we need. We can run our tests again to make sure that they work, and we can run code coverage to make sure that that works. And you can see that we didn't have any files again, but this is the expected output that we've got. So we've got our linting, our testing, our code coverage, our basic files set up here, NYC output for code coverage output. So we're pretty much ready to go. So now we can go ahead and create the actual app. Okay, so here's the code we have so far for the binary search tree for this exercise. And you can see here we have tree, class tree with an add node that basically looks down the left side, if it's less than, sees if it's blank, adds the new node, recursively continues down, checking here's the right side, seeing if it's blank, adding the new node and doing that recursively as needed. And then the node is a very simple class there, and we export that. And you can see we've got 6 passing and 4 failing. So let's take a look at the tests. Let's go this up a little bit. Let's see what's passing simply here. So we've got a binary search tree with a root node. We can do a second country, which is what this exercise is about. Countries on a tour. And we can do an alphabetically greater than or less than. And then we've got the failing 4 tests here. When searched for, that's failing. Can't show this. When searched for, when searched for. So all 4 of those are failing. 6 passing, 4 failing. And so going back again to the tests here. Open this up at the top. Okay, so the tour exists. And the countries, we can add a second country, won't misspell, but we can push a root node. A tree is a tour and a node is a country. So that's what the translation. Okay, and so we can push the root one, add a new one, Australia, add that in. There's our add node method. Then we should have 2 countries. The left is the second, the right is the blank. If we add Zaire, Z at the end, as opposed to the A, it'll go on the right. So the left will be null and the right will have the second node when we use add node. Sort of the opposite to what the last one, the test did. So testing both sides. And then, so all these tests work until we get to here, node. This one works. Here's our first one that doesn't, the node exists. It doesn't exist yet, that's our challenge. So it's a pretty simple DSL, pass in the name of this country and say get true or false back. Alright, so it's a little hard to see here. We're going to add this new method into this class here. And, okay, so let's call it, the last one was add node. We already know what it's called because we've got tests that call it, so it's called node exists. And we're going to pass in the name of the country. That's what this method's about, just seeing if it exists. And, you know, maybe you don't, but potentially long term, this could all just be one method along with add node. But for now, we just want to separate it out. We can merge these 2 methods together as part of the refactoring. But just to make it kind of more simple to do the exercise, we're just going to break out the specific method with its own name. So we'll start off right at the root. You know, if our name is that root name, and we don't have root, so we need to have something that represents that. Well, we know it's the we can also use this construct we created, this .countries of 0. That's the same as the root node for this class in countries. So if that's true, well, then it is true. So we'll return true. Okay, so that's a simple condition. Again, we're just starting at the root node. We'll need to change this when we recursively go through, but we'll get to that when we come to it. So the left-hand side, if the name is less than this node we've been looking at, which for right now again is the root node. So if the name is less than that root node's name, then we So we're going on the left-hand side now. We will want to do another check and say, is it actually that? Again, root node for right now. Yeah, I mean I could change it, but let me just do it. Keep going. Countries of 0. So if it's here's where we check if it's actually null. It doesn't exist. So we've reached a leaf and then nothing below it, leaf node. So in that case, we can just at that point return false. And so now we need to do that recursive call. So if we say if it's equal to, so if the name we passed in, if it's equal to that, this time because we're going down on the left, that root node's left name, I actually want to compare the name, then return true. Again, we found it. And then we have the recursive call, where we say at this point we're still traveling, so to speak, down the tree. And so we call node exists. We pass in, keep that node, keep that name, sorry, and what we pass in now is the current node dot left. So that's going to need to be we're going to need to add that parameter, and we're going to need to change this hard coding of the root. So instead of actually hard coding that, let's give this a name. We're going to have a name for this. So get my editor to be where I want it to be. Okay, let's change this to be current node that we've got. So we're going to pass that in. So let's add that as a parameter now. So let's put that here. We still want to start at the root. We're going to have to figure out that. So we just set it here. Thank you, default parameters. So that's where we can put this dot countries of 0. Okay, so now we can start. There we go. Replace with current node. So if name is less than current node, and the same for this one. Let's do that replacement, and same here. Oh, that wasn't quite right. Let me just fix this. Put in the period here. Okay, get something else still not right. Whoops. Delete that. Okay, now they all light up. Thank you, editor. Okay, so there's still something actually wrong here. These are white. So I have to click away to see it. And look, close paren. There it is, right in there. Oops. Okay. Alright, so we're all good. This is for the left-hand side. Again, these are our different conditions that we want to check for. Else go back. And let's try running this. Let's give me a bit more room here. I clicked on problems. Let's go back to terminal. Okay. And passing error 22. So, do I have my close paren? Okay, this is a little bit hard to see. Something is not quite right. This is a little bit hard to spot. This is kind of crammed in here, so let me create a little bit more visibility to this and scroll up. So we can see what the problem is a little bit more. Alright, so it's kind of hard to see. But now with a bigger view, maybe you can see that node exists wasn't actually aligned with add node. So it was actually within add node, so to speak. It wasn't a separate method of its own. So let's fix that let's fix that by moving it down actually. So let's delete that. Go down here and paste that in there. Alright, so it's not showing problems, but of course our indenting is all wrong. So let me just use my bin bindings here to select an equals and okay. Now node exists at the same level as add node, so that should be good. So that was kind of crazy, but let's continue. Alright, now we get node exists is not defined, which is kind of surprising. given what we just did. It is at the right indentational level. It is within tree. So, a little bit of a mystery. So, 7 passing though. So, another one passed. And first we did the left, and then we need to do the right. So we do expect some of them to fail. So that may be what's going on here. And you can see it's line 28. Here. I think this, let's check it one more time. 50, let's take a look at the, these last 3 linting passes, and at line 50, so let's go to line 50, let's open this up a little bit, I can grab that. And, okay, so this is the exact tool that exists, so a non-existent country, no, sorry, Sudan, which was also the root, so they're actually equal. So this is an interesting test case here, where this was actually unintentional, where we added the same country, but it's actually exposed a bug, so to speak, if that's allowed. But let's do. I think I'm actually going to do the right-hand side here. So let's, so we know it wasn't less than, so we know it's greater than or equal to. So the next condition was checking the right-hand side to see if that is null, in which case it doesn't exist, so we return false like we did up here. Actually, we didn't actually check the left side here, so I think we got a false positive on our tests there. Let's fix this while we're here. And so we had the left there. Alright, so it was only in one spot we had that wrong. So return false, and this is an exercise that's hard to tease out through tests, given the formula that we're using here. To some extent, you might as well just get the formula and copy it in, but I'm trying to use TDD and BDD to discover it as best I can. So we're doing the right-hand side, so we check for the right name. We check to see if this name that we've been looking for is the current node's right's name, which is fairly readable, I think. And if it is, return true. And then our next condition, now is when we call it recursively. Again, node existed name. And we pass in the current node. So that's us, the current node's right. We're on the right hand side, traveling down that for this particular branch. The next branch may be left. Alright, so we've got our exports, got our method, I've got our new method here. And it all looks pretty good. I think we're ready to try running a test, so let's do that. Save that and run a test. Alright, how close are we? Ooh, 9 with 1 failing. Well, that's pretty good. This is actually back to we spotted this before. We jumped around a little bit here. This was when the node was actually equal. We added Sudan as a root node and then added Sudan again. And if that's allowable, if we have a test case, if the user says that's allowable, then this should have been name here to actually make that work. Nice, 10 cases. So all of our tests work now. Our new function node exists works. Just sort of looking it over to see if anything jumps out. Those false negatives and positives can be kind of scary. So see all examples here. Here's the adding a node and then adding Zaire, making sure that the second and third node work. Okay, so all of these examples are working and all our tests are passing. And let's look at coverage, of course. I'll try to be 100%. Ooh, it's not. 75 branch on lines 12, 19, and 32. Well, we're not going to fix that right now for this exercise, but let's take a look at it. You may be curious as to what's going on there. So let's take a look at line 12. And this is quite common. You see, we call something, we pass in a couple of parameters. So that usually means we're not testing one of the combinations. Maybe we've got a default there. And it's the same on line 19. And that's the other example, same reason. And then on line 32, again, parameter combinations. Looks like we're not testing all of the different combinations there. So that's something we should fix. I'm not going to do it right now. We'll do that in a later exercise. And I think we're done. Thank you.